Okay, we're back for a surprise stream of Advent of Code 2022 Day 21. You may be thinking, oh Kevin, I thought the last two streams you mentioned the streams would end after day 20 because you said that you would be leaving. Well, technically I should be on a plane right now, but Vancouver got almost like 24 centimeters of snow or something over the past 24 hours, and Vancouver International Airport stopped accepting all inbound flights, and outbound flights haven't been happening either. And so the flight that I was supposed to be on got cancelled. So that's kind of unfortunate, but the silver lining is that I'm still around to do Advent of Code. Sure. Either way, we're here. Back to hopefully earn some points. Maybe it'll lessen the blow of having my flight cancelled if I can get some points, so we'll see what happens. A1 op A2 equals desktop split. Okay. I guess it's a topological. Maybe we can represent it this way. So that relies on these ones. So we can do a graph of m dot add a1 dot a2 this work? Okay, and then I guess we could just reverse it, because like CZ should be okay. It's that. Ops. God. M equals res monkey is going to be equal. We'll do it this way. Sure, it's going to be what? It should be res of Wow, why did you go so fast? Be equals, which means that it still listens for two numbers. Oh. Oh dear. Okay. Optimization question. Huh. How do we optimize this? I guess we try different values. So all we care about is we need the graph. It's going to be res of human is equal to human, and then ops of root is actually should be equals. Should be A1 equals, and then A2. I mean, it's definitely like not gonna work, right? It's gonna be some crazy optimization thing. logic does not support. Why is this? Oh, I'm like overwriting something. Oh, yeah. Of course. So like, this definitely is not gonna work. So we kind of want to look for patterns. I mean, we're welcome to do this, but it's gonna be like one of the breakdown puzzles. Either find a pattern or break it down. I, A1, A2. Okay, I mean, it just increments up, so what is it on our real input? Does this change at all? Why do we have decimal numbers? Oh, okay, we're doing math here. So this stays the same. Oh, why is a Windows calculator so big, huh? $64 is the delta, so the answer should probably be what is this minus this is equal to this, and this happens every 64. So it should be this divided by 64. This should be the answer? Wait, every 4 it moves 64? Oh, so it's divided by 16. Whoops. It should be this number. Divided by 16 is the number I want. And how come my math is off? It resets? Huh? 10K. Is it trickier than that? Okay, that's never gonna happen. That's just a waste of time. I'm so confused. I think we want to skip by 1, 2, 3, 4. Oh, we want to skip by 5s, I think. And let's start us at a better number than that. Let's start us at 4. Give me 4. Sorry, give me 5, I mean. Sorry. By that I mean give me 2. Yeah, shouldn't it be... It's fairly consistent, no? Every 5 we go down 64? Oh. What's every 5? So if this is the difference, it should be... Oh god, what's the math? Every 5 we lose 64, so it's divided by... Is it 64 over 5? Or the other way around? What if this is a good number? Or was I supposed to divide by 5 divided by 64? I think. I mean, 4 times 5. I think this is the number. Yeah. Okay. We were too slow. That was pretty good though. I'm kind of satisfied with this. I wonder who hit it. I'm looking for... I'm guessing Robert got it. Ah. People are so fast on the first part. Maybe they just brute force it. Oh, Robert. Wow. Robert with a solution in almost only a minute for part 3. Cool, well, I'm pretty happy this is kind of a return to form, even though we didn't hit leaderboard. 127, 115 is significantly better than we've been doing in kind of the past 2 weeks, so I'm quite happy with that. And this is a good problem to talk about actually. We can end the night early, so I am going to jump back into real time and explain the problem. Whoops, I got a little too into, okay, we'll fade the music by not being a great streamer, just clicking mute. Got too into cleaning up the code. I'm gonna probably have to be doing this a little more before jumping into the problem, but, or we can do that as we go. I just want to do a little bit of cleanup before we go into it so that the explanation actually makes sense. So please bear with me. Let's just first of all solve part 1. Let's ignore all of the stuff for part 2. Let's return yells of root here, and then just say part 1 is going to be simulate and then do if human, do this. Let's just completely ignore that. Dot exit. Okay. Are we good? $152. Okay, cool. So this problem is called monkey math. And basically we get a list of these. Each line represents a monkey. So the first word here before the colon is the name of the monkey, and the thing after is what the monkey yells. So each monkey either yells a number or yells the result of a math operation. So this monkey here, DBPL, would yell the number 5. Simple enough. But some of the other monkeys will yell a math operation. And so for example, this one, the number that this monkey CCZH yells is whatever this monkey yells plus whatever this monkey yells. So you kind of have to work backwards and figure out what it's yelling. So here, I guess we got lucky. This one, we can just look up here and it's going to yell 4. This monkey here, it's a little more complicated, right? Well, it's going to yell the result of this times this. This monkey is going to yell the result of, this minus this. And you can kind of see how this chain goes on. So I think there's 2 ways you could have solved this. I think one of them is sort of a brute force method, and I kind of just want to see how big the input is. The real input looks like, well, I can actually just run it. The real input is 2,400 lines. Something you could do is run through all of the monkeys, and if any monkey has 2 things that are correctly resolved, like if I know what this monkey is and I know what this monkey is, I can just replace it with the operation and just run through and keep on running through until the list is fully resolved. That's one way of doing it. Maybe it was actually the right way you're supposed to do it. But the alternative, which I decided to do, is to perform a topological sort on this list of monkeys. A topological sort is an algorithm that you can use to determine a list of dependencies. And so in this graph, it's a directed graph, and we can sort it, quote unquote, into a set of orderings. And this ordering here guarantees that nothing that, so the line kind of represents a dependency. So for example, 11 depends on 5 being completed and 7 being completed. And so 5 and 7 will always come before 11. You can see that in any of these various sortings. And so why is this concept useful to us to solve this problem? Well, if we can do a topological sort on the monkeys and say that the root monkey depends on knowing what the result of yelling this monkey's yell and this monkey's yell is, then we can get an ordering of who we can resolve in reverse order. So at the end of the list, like who doesn't depend on anyone? Well, it'll be all the monkeys that already know what they have to say because they have no dependencies. Then the monkeys before that will be precisely the ones that depend only on monkeys that already know their number, and so on and so forth. And so this is pretty ugly code, I guess, but let's clean it up a bit. So I guess we get the monkey name out from splitting the line here, and the monkey either yells a number like this. If the rest of the line here is numeric, it's just a monkey that's yelling an explicit number. So I'm going to put that into a dictionary called yells. Otherwise, it's some math operation, right? So we have to store that operation for later so that we can resolve what the monkey wants. But I'm also going to add it to this graph. So like this, the m's have to be replaced with monkey. And so this graph gets constructed so we can do a topological sort on this. And let's just see what this looks like. Let's do print top sort of graph. So if we run this on this, we get this ordering. We see that at the end of the list are ZC, ZC, which is like this monkey, it has no dependencies, right? And as we would expect, the root monkey, the root of the dependency tree, comes first. And like PPPW and CCZH, they come pretty early on. Like root depends on this one. This one seems to be a pretty early dependency of that too. And so this is important because if we work backwards in this list, we know that every single number, if we go in reverse order, its dependencies will have already been resolved. Or by looking at the code, we know that the results of this monkey are already somewhere in this yells dictionary, right? And so we work backwards in the list of the topological sort. And if the monkey is in ops, or I guess it's probably better to say if monkey is not in yells, like we don't know what the monkey is yelling yet, I'm going to grab the values, so it's two dependencies. Maybe like D1 and D2 are better numbers or better letters for this. Let's replace A1 with D1. And do the same thing for D2. So these are like dependent monkeys, right? We're going to grab it out, and then we're going to do some pretty gross code. Rather than writing a bunch of if statements, what we really want to do here is just say yells monkey is going to be equal to whatever the the D1 monkey is, right? And then whatever the operation is, which might be like the plus symbol or the minus symbol or the times symbol, and then we want to do the D2 monkey, right? We just want those values. I guess this actually can just, it's probably better to do this. In my haste, I wasn't really thinking. I was just trying to get eval working and I was scared. But I think this works. Yeah. So we're just evaluating this. We're telling Python literally execute, this math operation. Again, not safe to do this on inputs you don't trust, but we trust what we're getting here. So after doing this, we will have resolved all the monkeys, what they have to say. And then we just have to return, what the root monkey is saying. So if we run that here, on the sample we get 152. I'm just gonna not print this out anymore. And if we run this on the real input, we get this really big number here. Great. So part 2 says we got the wrong job for the root monkey. So rather than root being like something plus something, or I think in the case of the real input, oh, it is something plus something. Instead, it's something equals something. And so we want to know when the two numbers that the root, the two monkeys that the root monkey depends on are equal to each other. Okay, that's fine. But the other thing is there's a human monkey in here. The human is actually us, haha. What a plot twist. And we are the ones who are yelling a number to change this chain of what all the other monkeys yell. Because you can imagine, we are a dependency of this monkey. And so if we change what we say, you know, all the monkeys afterwards are going to say something different. And so in this sample example, the number that we're yelling gets to 301. If we yell the number 301, then this monkey and this monkey will say the same thing, so the root will be equal, right? This is equal to this, which is great. So on the surface, it seems pretty simple, right? We can just, let's see, what do we want to do? We want to replace, let me work lower down, I guess. So we'll do a simulate part 2, just for the sake of explaining this. We'll just replace the root with saying, oh, are these two things equal, right? And then we'll do the exact same thing. And then we'll just say for human in range, I don't know, we'll try numbers from 0 to maybe 500 or something like that. We will, the answer is going to be trying to simulate this, and we'll say, oh, the human number is going to be this, right? And then we should also make it so that, you know, we replace what the human is yelling by this parameter that we're passing in. And then if answer is true, then we'll print the, say, oh, the number we should have yelled is this number for part 2. I guess something else that we have to do is we want to be resetting these things every time. I guess the topological sort is always the same, so maybe that is not as redundant. I think we only have to topological sort once, so we can actually improve this. We can say ordering is going to equal reversed top sort of graph. And so the ordering is always fixed. And so for each monkey in the ordering, because the graph of how the monkeys are related to each other are never different. So that's great. And then this should be all we need to do, right, for part 2. Oh, we do that. This shouldn't be happening. $152. Oh, does that really get redefined? I need a Oh, sorry, I forgot to do what I was saying. So we want to change, you know, okay, we don't need to pass the graph in anymore. That's fine. So we can remove that from here. But we do want to use a fresh version of these yells and ops dictionary every time, because depending on what human is, that's going to change. So we can use the copy module to just copy these over and not actually mutate the original variables. So if we do this, really? Now what's going on? Let me just do some real quick debugging here. Oh, we're mutating it on the first go of this one, of part 1, so we need to copy it. We're already kind of fixing the yells things. So let's do that. Okay, this seems better. So let's not do that. Yells monkey, if monkey not in yells. Okay, I guess, can we do this? So the root monkey relies on p. We're not going through all the monkeys for some reason. But I'm not sure why. Is it because our ordering doesn't contain everything? That doesn't seem right. Oh, it's an iterator? We have to turn to list, so we iterate over the whole thing every time? Okay, great. Okay, sure. So in this case, to simplify things, instead of returning the actual value of the root monkey, let's return this value and this value so we can compare them. So the dependency 1 and dependency 2 of root. And if d1 is equal to d2, we'll print the answer to part 1 and we'll break, right? So we try a bunch of monkeys and we find 301 is the right one. And that's the answer. Great. Seems simple enough. Let's try it on the real input. And let's actually also, it might be a bit bigger. So let's also print out, what iteration we're on and try it on the real input. So it runs for a bit, 301 definitely wasn't the right monkey. And you'll see the correct answer was something in the millions, billions, trillion. Wait, this would be the millions, billions, trillions. It was 3,220,000,000,000 something, something, something. And so with this approach, you're never going to get up to this number in a reasonable amount of time, right? So the trick is we need to think a bit more clever about this. So we know that if we change this number that the human is yelling, it's going to affect the monkey somehow. So let's inspect what happens when we change things and see if we can make any inferences about it. So let's just try to run the first 16 maybe, and at every given point in time, we'll print out what human we're on, what the D1 monkey thinks, and what the D2 monkey thinks. And we notice something kind of interesting. The D2 monkey is always saying the same number. Oh, and the reason why we're getting point zeros here is because these divisions in Python 3 are being handled as float division instead of floored divisions. And so any division in this chain of operations will cause it become a float or not, but it's not a big deal. First thing to notice is we see this interesting repeating 068 024 68 024 68 024. Okay, that's kind of weird. And that the D2 monkey isn't changing at all, right? So I think what is important to do is when you notice something like this and these numbers are very similar, it looks like the difference between each of these monkeys is potentially the same at every step, right? And so what I did is whipped out the trusty Windows calculator that was completely like comically massive. Are there better things that we can do? Oh, a programmer calculator? Wow. Let's use the programmer calculator because we're programmers. Let's see what the difference is between the 3 result and let's subtract the 8 result. Just because I don't want to deal with these decimals, let's see what the next whole numbers are. We see we go forward 64. So between iteration 3, so if the human yelled 3 and if the human yelled 8, it's a difference of 64. Let's confirm that this doesn't change at all. So we'll try going from the human equals 8 to the human equals 13. Whoops. So we'll subtract this. I think I might, oh. Did I click decimal to turn it into, the programmer calculator messed me up. I think I accidentally clicked that, sorry. If I take this and subtract this, we get 64 again. So we could be relatively confident about this fact that with this given input, when the human number increases by 5, the number that the D1 monkey is yelling decreases by 64. So if that's the case, all we need to do is figure out, well, how many jumps of these cycles do we need to get this number down over to this number over here? And so it becomes just an arithmetic problem, right? If, so every 5 human counts, D1 monkey decreases by 64. That's one fact. Another fact is when human is equal to 3, D1 equals this, and D2 equals this. We want D1 to equal D2, so we should figure out the difference, right? D1 minus D2 is equal to, pull out the handy dandy calculator, this minus this is going to be this number, right? So then, because every 5 human counts, this monkey is decreased by 64, what we actually want to solve is, well, how many human counts do we need to jump? Well, it'll be this divided by 64 times 5, right? Or yeah. Technically, it would be like, you know, like this is how I would think about it conceptually in terms of the math, but just inputting it here. Like, wait, why am I using that calculator when I could have just been using like the Python like CLI? If we times this by 5 over 64, okay, what we want to be doing is this, because every 5 human counts, we jump by this much, and the number decreases by 64 every 5 human counts. So we want to figure out how many cycles of human counts do we need to go through to get to having these monkeys equal about each other. And the answer seems to be this, if I did my math correctly around this time. So let's just test that out, right? This is the wrong thing over here. So let's peg our starting number at this, and we'll start around here and end at maybe start plus 100 because there might be some leeway either way. And run it. And we see that we got pretty close to start with, right? I think we were actually just off by a little bit, but we find the perfect number here. This number here, the D1 monkey is equal to the D2 monkey, and it happened to also be, the answer to part 2. So every advent of code, there's usually a problem that a computer cannot solve in a reasonable amount of time just by naively iterating through all the things, and it's a question of inspecting how your problem input behaves, and kind of doing an analytical solution, like you're analyzing the output and figuring out as a human intelligently where what the answer should be. You can work this out mathematically given the behavior of this program input. Could you solve this with like any given input? No. You're not. With almost every single input, you're never guaranteed that the output here is going to follow that same pattern of like every 5 human counts, the number's going to decrease by a fixed amount. I wonder if there is some guarantee, like this input was specifically crafted to have that behavior, and depending on your input, the constants here, like this by 5 over here or this 64, might be different, and it probably is different, but there will be constants that you can observe and solve like this analytically. But yeah, that was basically day 21 for Advent of Code. Again, pretty satisfied. We didn't leaderboard. We were very close. I wonder how close we actually were. It closed at 16:15, and we were 17:22. So we're a minute too slow, and probably about a minute too slow for part 1 as well, if I had to guess. Closed at 4:28, and we were 4:49. So yeah, I guess people kind of probably just like brute force this or just implemented the solution a lot faster. I'm surprised. Maybe brute forcing would have been a decent solution, but I this year added topological sort to my utility method, so I was eager to use it. But anyways, yeah, happy about this part 2. Sad about my flight being cancelled, but we had a good day in Advent of Code today, even though we didn't leaderboard. So hopefully, maybe back for tomorrow if nothing changes with flights and stuff. But yeah, this was a good day, so thank you for watching.